All right, ladies and gentlemen, it's 3 minutes past the hour, so why don't we get started? Again, you are at the Introducing Qumulo NeuralCache webinar. Thank you for joining today. We appreciate you attending. We hope you find this valuable. Why don't we go see who will be joining me today? I have three great panelists alongside me today. We have Brandon Whitelaw, who is our field CTO as well as GM of Cloud at Qumulo. We also are joined by Matt McMullen, who is the principal software engineer on the NeuralCache project. And then we also have a customer, Jeff Drury, who is director of technology at Carbon. So for today's agenda, we hoped that you'll come away understanding how you can accelerate neural workflows with Qumulo NeuralCache, how to optimize data movement for large-scale file-based workloads, and how NeuralCache is able to achieve 96% cache hit rates, as well as reducing your API charges to object storage by 99%. We're going to have a few demos to demonstrate it in action, as well as have Jeff come on and talk about his experience with the NeuralCache. And we'll go to the next slide. And so first, I'd like to introduce Brandon Whitelaw. He will be giving us a great deep dive into how NeuralCache works under the covers. Brandon?
Yeah, thanks everybody. Great to be here with you. Coming live from sunny Phoenix, Arizona, where believe it or not, it's already in the low 90s. So heat is upon us. And when kind of reflecting upon the theme for today, a great quote came up, which is that the future is now, it's just not yet evenly distributed. And I feel that's the way, kind of reflecting upon the impact NeuralCache has to our technology and how we empower our customers, moving towards using the world's most advanced file system to connect data to services, people, and the needs anywhere it may be, from on-prem to the cloud at the edge. So with that, I'll walk you through some of the deep dive of behind the scenes, kind of the special sauce on NeuralCache, and then obviously pass it over to Matt to go and show you it in action. So first, there are two main core technologies that NeuralCache impacts for us. The first one is relative to our cloud-native Qumulo file system, which is just exponentially growing like gangbusters. Now, we have customers adopting now what originally took the first year for the platform every 5 days. So exponential growth, and really where that's coming from is customers the ability to truly have a what I consider as the world's only truly cloud-native file system in any hyperscaler technology today. Really coming back to my original AWS onboarding training, focusing on three core tenets. The first one being paying for what you only for what you use, no pre-provisioning, no paying for performance if you don't need it, or binding of capacity and performance together. Truly just paying for actual usage, both not only on our licensing, but the underlying primitives within the hyperscaler. True elasticity, being able to independently scale performance from capacity at any time within minutes to meet the most demanding of variable workloads, from accelerating AI ML pipelines to deep, cost-effective archival for PACS medical imaging and any of the extremely demanding media workloads across the board that we serve as well for our customers. And then truly boundless scale, being able to have something that reflects the underlying primitive like S3, where you have, in our case, with Qumulo on top of it, really no file size limitation, no file count limitation, no performance limitation, and really no protocol restrictions. Ultimately, this leading to customers avoiding what previously was inhibiting file workloads from moving to the cloud, which was expensive and lengthy refactoring of applications, or lifting and shifting of applications and not really maximizing the true potential of being cloud native. So we kind of like to joke that, our engineers did the hard right thing over a number of years to re-platform Qumulo to be cloud native so that you don't have to for your applications to get all that benefit, and just really accelerating that adoption. So next, what we'll cover is really the enterprise capabilities, the uncompromising capabilities of cloud native Qumulo that NeuralCache empowers, which is really the simplicity of scale, the enterprise-ready multi-protocol access, full application compatibility for all legacy and file-based applications, being truly multi-protocol from SMB, NFS, and S3 all to the same data at the same time, with the strictest of compliance and regulatory governance. And then really taking away the risk and complexity and uncertainty related to sometimes those cloud-based workloads. So no risk or concept of capacity planning or over provisioning, and yet still delivering a cost characteristic, especially when considering the higher levels of durability and reliability of even replicated systems on-prem, of comparable to on-prem total cost of ownership and true pay-as-you-go pricing. So all this net works out to allow customers the freedom to be able to put their data in any location and any type of data with total control, and being able to accelerate those workloads where necessary to align the data in the right place at the right time. And if you want even more about this, we have a previous webinar that goes even further into depth on Cloud Native Qumulo if you're interested. So moving on, the other aspect of where NeuralCache comes into play, and we'll talk about today, is around our relatively new cloud data fabric. So this is really the world's first deeply embedded distributed namespace technology directly in the file system under the protocol level that, as we talked about in our just last webinar, really allows you to seamlessly connect any Qumulo directory to another one and represent that data locally, even though it's remote. And because you have directory level granularity, this really allows you to meet the utmost of compliance related to data sovereignty, GDPR, or regulatory restrictions, whether it be point-to-point on-prem, on-prem to cloud, cloud to on-prem, and really allows you to kind of rethink architecturally your data strategy globally about how you place data and how you connect that data seamlessly to distributed teams, services, compute, wherever available. We have a tremendous adoption of this being so new, and the feedback has just been amazing. The ability, there's a lot of it's like magic, the comments that come out, where being able to instantly represent petabytes of data, billions of files that are on premises into a cloud infrastructure to on-demand spin up burst render workloads, AI pipelines, early tumor detection for healthcare customers. It really opens up new possibilities of how to use the forefront of advanced technology from a service perspective without necessarily going through a complicated and painful migration or replication of data and copying of data. And all this comes down to not beating the speed of light, but really beating the laws of time, the fourth dimension, really, in being able to preemptively move data ahead of its need to make the end user experience and applications have the utmost of performance, even though the data is not persisted there locally. And all being done in an extremely simple and automated way so that you don't have to manually manage any of that. So with that all said, the premise of Cloud Native Qumulo and Cloud Data Fabric, and obviously our on-premise systems as well, let's kind of talk about the secret sauce of this is just today's focus, NeuralCache. So, Qumulo has had a preemptive cache technology in place for over 12 years, but really and I'll go into the details of that, but what really kind of steps it up here is being able to take on new characteristics of data and training to be able to deliver NVMe-like performance at the cost of object when it comes to Cloud Native Qumulo, or being able to present data to remote systems as if it's local and getting local-like performance, even though the data is in some circumstances on a different continent. This also helps with an order of magnitude reduction in API costs relative to this, especially when using our Cloud Native Qumulo instance, which will show you the data on that, which is just astounding. The first time I heard that Qumulo was going to have a Cloud Native instance running and persisting on hyperscaler object systems like S3 or Azure Blob, I thought, well, okay, that's great. I don't know how you're going to make it performant, but also I don't know how you're going to avoid being just brutalized in death by 1,000 slices from API costs. And so what we'll show you today is it's pretty drastic. It's actually even better than just native object in many ways. So this is all about preemptively caching data without manual intervention, without active management, to make it so we can accelerate those workloads no matter where they are. So next, we're going to talk about how it does this. So the simplicity at speed comes from actively matching against pre-trained digital twin patterns, the most common applications our customers used, in combination with all the other years of training we have built into the system. But this allows the system to automatically recognize patterns and anticipate data the client's going to need next, and then prefetch that into the local cache before requested. So this is not your typical most recently read or written data type caching systems you see in most file systems out there today. This is actively monitoring in real time which of the different algorithms would best optimize for cache hit rate and cost optimization, and then immediately swapping those into place in sub-milliseconds to optimize for the workflow, looking at how the data is laid out, the type of data, the behavioral patterns, and those application optimizations, and constantly trying to match the best inference pattern to get the highest cache hit rates possible. So that pattern analysis is happening on a directory level basis and actively in real time being altered or changed to maximize the output for customers. Again, all this without you having to manage or set or specify anything in the file system. Next. So how does this all come together? Well, there's a lot of factors, and only so much we can give away in an open public forum, but I'll give you some of the basis to kind of back it up. Yes, of course, the algorithm looks at the user data, the behavioral patterns, the date and time of the files, what type of files are they associated with what applications, how they're laid out in the directories based on their naming pattern or types of sequential naming of them, of course. But I would say really where it all comes together is two parts in maximum difference. First, over 12 years of telemetry data across thousands of clusters, totaling at least 264 trillion data points, went into training these models and building upon really a company-wide experience of how to optimize these file-based workloads for customers. That progression over time optimized between spinning disk and SSD on premises and still does. But when you move into a federated distributed namespace, those data portals between sites, being able to optimize data to transition between site to site means you really have to get ahead of it. You can't wait for speed of light transfer. You have to get ahead of request. And so that data and experience plays a huge part in that. And the second part that is really impactful in this is what we call our digital twin regression testing modeling. So this is where we're able to, anytime any of our customers find a use case that for whatever reason is novel or different or really rare, we're able to take that, capture that as a digital twin fingerprint of that application, regression train on the model to optimize for the best performance possible, and then create a persona or fingerprint for that gets embedded into the pattern matching system. And again, this is being done on a directory level basis and always constantly trying to be optimized. And so that continuous review and optimization just creates tremendous performance output that's really night and day before even what it was doing previously, which was quite advanced compared to most other technologies out there, but now it's just next level. So let's take a look a little bit further of how we go on this as well. If we could go next. So this is all on the read side, but what about the write side? Well, this is really, really important, especially in an object environment where every single time you touch data in any way, shape, or form, you pay for it. Kind of death by 1,000 slices for API costs. And so what NeuralCache does in the cloud as well is it takes every single write operation, only new created blocks from a 4K block perspective in modifications or new files. It compacts and compresses those together. And so it avoids a lot of what you're seeing here on the system itself. Without NeuralCache, every write operation would be a put. Every put operation would induce latency. It would increase cost. In fact, we had a customer, as you can see on the right, where they were kind of modeling using a application for VNA in the medical industry that was, every file was an object and writing those images into either S3 standard or Glacier Instant Retrieval. And what was astounding to me was that how fast the bill racked up in modeling this cost. A lot of people may not know this unless you're in the industry, but X-rays and medical images are actually really small. About, in this case for this customer, about 110 kilobytes on average in size, and each one of those was a put. And so this customer had 40 billion files on the system, and to write that into Glacier Instant Retrieval just once, just the first time, let alone use it later, was going to be $800,000 in API costs. So let's contrast that to what it looked like on Cloud Native Qumulo with NeuralCache. If we go next. So a couple things here that change quite drastically. First, NeuralCache commits all rights to mirrored and striped EBS volumes in the case of S3 or uh, uh, managed disk in Azure and equivalent other clouds. And this really, really minimizes latency. So the latency path is extremely good, extremely high performance, better than you'd ever get out of any single EBS instance. And then it instantly flushes as fast as possible. So we use this as a temporary, highly durable, resilient write cache where we can compact and compress objects. And that object stacking in compaction and compression obviously not only ensures high durability in what we do with this, being able to mirror these across nodes, even across availability zones in the cloud for very, very high durability on write. So there's never any data loss, even in the utmost of outages. But it also optimizes the cost characteristics by how we compact and compress those objects. And so in that example I gave previously of up to $800,000 in API costs. In contrast, if written through Cloud Native Qumulo with NeuralCache in place, it actually reduced it down to $655. So not 655,000 versus 800,000, 800,000 versus $655. Pretty drastic difference there, and the benefit, especially in these high file count environments. So we go next. I think let's kind of wrap up the takeaways. I think the benefits are really more important, even more than the details of how it does it. I mean, at the end of the day, you just want it to work and work well. And I was extremely surprised by the outputs evaluating the entire global fleet of how our customers use this technology. So across data portals, across cloud native Qumulo, on-prem in our systems, we see a 96+% cache hit rate. Now, applications vary in their randomness and how they're characterized, but this is the global fleet average. The lowest we've seen is actually only 80%, which is still ridiculously higher than most systems, but it basically means that 96+% of the time on average, you're getting NVMe-like performance at the cost characteristics of object and local-like performance at the characteristics of not having to replicate or copy data, which of course means no single source of truth and paying for data twice. We want to avoid all of that. So just being able to seamlessly connect your data from on-prem, from one site to another site, from region to region within cloud to cloud, or on-prem to cloud, or vice versa, get local-like performance to remote data at tremendously high hit rates to really make it work like magic. From an API perspective, most S3 buckets range in 10 to 15%, sometimes as high as 25% of the cost per month is in API usage costs. If you have really high performance workloads, I've seen it at multitudes more than the cost to store an API costs. And yet our global fleet average across the most high performance workloads and everything in between is sub 1% of all costs being API costs. So it's really a rounding error and takes away that variability and uncertainty and risk that normally comes from those workloads. Overall, with our previous preemptive caching technology to now NeuralCache, we see a 2.7x improvement in read performance. And on a very, very strong adoption curve now for new workloads on AI and data model complexity, a massive reduction in the complexity of those models by being able to directly point the GPUs at a high performance shared storage NeuralCache that's really accelerating data from S3 or Azure Blob and allowing you to have much, much larger data sets and being able to really get that, if you look at training models and LLMs, extremely read intensive workloads, hitting that cache, getting that high performance, and yet not having to stage or copy data into the local disk of those GPU instances. So really astounding across the board. Let's go next. I think at this point, actually, I would love to get Matt on board. And Matt, if maybe you could just do a quick introduction for yourself and maybe show us the results in action.
And Brandon,
Yeah.
Matt and
Oh,
Brandon, let's take a quick pause here. We've got a few questions coming in. I'd like to take the opportunity just to make sure that we address them before we get too far along. And folks, remember, Q&A is open and available, so feel free to drop those questions in. The first question is, does the 96% extremely high cache hit rate include video editing workloads?
Yes, it does. In fact, Jeff will talk, our guest speaker here will talk about it in a little bit as well. But in particular, there's an application there that traditionally has been what I call kryptonite to file systems, where every frame is a different file and normal prefetching doesn't work. And yet, actually, even higher than 96% rate, we'll show you in just a little bit as well.
And there's another fantastic question here. It seems like AWS would be unhappy with this optimization and might see this as taking advantage of their current pricing model. What is going to happen if AWS decides to change their pricing to adapt to your model?
Well, as someone who used to be in charge of worldwide go-to-market strategy for AWS storage, I can tell you that, look, at the end of the day, AWS is a bottoms-up utility pricing model where they look at the underlying costs and then work up from there on pricing. And AWS has never raised prices, has always lowered prices over years, and always looked for ways to help customers cost optimize. In their logic, it's really simple. If they don't disrupt their own pricing model to accelerate adoption, someone else will. And the more that they can cost optimize and save customers money, the better and more likely you are to launch new workloads and new projects in AWS. And so actually, we've had tremendous collaboration with the AWS teams. Actually, the majority of all of our opportunities for our AWS product have been originated by AWS because this lowers the barrier of entry to move those workloads into AWS and normalizes the economics that previously were multitudes more expensive for storage.
Fantastic. And then one last one before we move on. Are you I think this question is asking where are we caching the data, but the question is, are you preloading into DRAM or into the CPU cache?
I think I'm probably the right one to answer that question. Yeah, here we go. Yeah, I think I'm probably the right one to answer that question. The answer is we're predicting what data you're going to access next based on the data that you have previously accessed. And we have a multi-stage cache loading process where first, when you're really far away, we load it to your local cluster. When you get a little closer, we're loading it into local NVMe. And when you get really close to when we think you're going to read it, we load it into DRAM on the node that your client is currently talking to. And it's a little bit about distance and it's a little bit about probability there. So you get like lower probability data can sometimes end up on local NVMe rather than in DRAM, and higher probability or closer data will end up in local RAM. The goal here is that you really want the customer experience to be that of like really super fast cached data all the time, not just when they've already read the data.
Fantastic. All right, why don't we go ahead with the demo? And again, Q&A is open, so feel free to keep lobbing those questions at us. We'll have another section at the end.
Great. Okay. Well, thank you, Dan. Thank you, Brandon. I'm Matt McMullen. I'm a principal software engineer over here at Qumulo, and I have been working with the NeuralCache project from the very beginning. I've been with the write side, the read side, the integration with our cloud data fabric, whole spiel. So I'd really like to show you how awesome this thing is because I'm pretty proud of it. What we have for you today is a demo for the performance. What we're going to be doing here is Adobe Premiere. It's a very performance critical application for its users. It's also fairly latency sensitive, so the performance really matters here. And it's also really visual, so I'm hoping that everybody here will be able to see the difference between something that is playing smoothly and something that's really choppy, right? And what I'm trying to show you here is a demonstration of the predictive capabilities of the cache. This is the performance, like the bit that's coming up right now. This is the performance that you should expect to see when the data starts out in an object. And this is the prediction engine behind the NeuralCache in action. So the goal here is, again, that we really want you to see the cached performance from the beginning. So right here, we have my little spider friend from the Blackmagic Pocket Cinema Gallery Bugs footage. It's Apple 4K, sorry, Apple ProRes 422 encoded 4K video. We've looped it and we've overlaid 8 copies of it on top of itself. That gets us about a ½ terabyte of demo footage here to just kind of emulate a pretty high intensity editorial workflow. Now, when we hit play here, you should see that once we get going, your playback is smooth. You see the dropped counter there is 0. We're not dropping frames. Your editor should be able to get their job done really quite easily. Then we scrub around and we can see the NeuralCache adapt. The data set is significantly larger than the RAM on either side of the connection here. So what you're really seeing is these prediction capabilities going and successfully predicting what the application's asking for and adapting on the fly. So I think I already mentioned this bit when we were answering that question, but I want to stress that what we're doing is we move data from object to local NVMe when we think you're going to read it soon. And as we get closer and closer, we move that data from local NVMe into RAM so that you get the best performance possible. We can hide all of that object latency from the many, many applications that just can't handle the latency impact that you have from object storage. And that also lets the business take advantage of the really awesome price dynamics of the object storage.
That's awesome.
Yeah.
I just have to say, Matt, like, especially doing this on a cold run, right? Not preemptively staging it, not making sure it's loaded into, NVMe ahead of time, manually staging or maybe having it scrubbed a couple times before it plays, just from a cold start, is pretty astounding.
Thank you.
So one thing I was thinking about is that's pretty amazing that it can be done at, on a local system. What if you want to enable remote teams to go from, one region to another region? Like collaboration, especially in the M&E space, is so active. So maybe could we see how this might work across a data portal with their cloud data fabric?
Sure. That's a really great point, and we have a lot of people who want to collaborate remotely. To really kind of drive home the point, what I'm going to show you first is what happens if you kind of set this scenario up more naively. So in the first part of the demo here, we had a Windows client in AWS talking to a Qumulo cluster sitting in AWS. And what you're seeing now is a Windows client in Azure in a region that's kind of far away from that first AWS cluster that we've connected to that cluster over in AWS. So this is just like, oh, hey, look, I have my storage over there. I have my person over here. Let me just hook the storage up and mount it for you, right? This is your naive approach to kind of global data sharing. So we load up the project and wait, still loading. There we go. And then you can see we're still loading in the thumbnails, and it loads in the thumbnails, right? So this is already, you can see that this experience is really not quite the best. And as we get to hitting play, you're going to see the experience degrade even further. And I think it's kind of important to understand what's going on here and why. So in this situation, we have really fast storage sitting over in AWS, but it's too far away from the client. The network latency that's between these two machines is just too high for Adobe Premiere to buffer past the issue. Adobe Premiere can't ask for enough data concurrently to buffer ahead of what the user's trying to do. And the result here is that the user gets a really bad experience. And it doesn't matter if the storage on the other side is fast, if the storage on the other side is too far away. So this is the problem we're trying to solve when we talk about this whole cloud data fabric. The flip side of this is, oh, hey, look, what if I just copied this data over so that the editor could then work with it? Oh, hey, look, now you've got two copies and they're getting out of sync because they're two copies. So with the whole cloud data fabric setup, we're looking to kind of solve this problem. And this is kind of a fundamental problem of network storage. We call it first, the network type. You've got the long fat network, and the property here where the application can't ask for enough data. That's your bandwidth delay product. So let's move on to the next slide, and we'll see. We're going to go to that same two client setup. We've got them kind of side by side. And in this case, what we've done is we've mounted another view into this file system via the Qumulo Cloud Data Fabric. So on the left side, you have your AWS client, and on the right side, you have your Azure client. And I'm just going to go ahead and make a file on the left, and you'll be able to see it show up on the right, just to show you like, hey, look, we're talking to the same namespace still. So we're not doing that whole thing where you copy it to be local. So the idea here is that with the Qumulo Cloud Data Fabric, we're going to go ahead and have this one namespace that's connecting the two clusters on either side. And we're going to go ahead and keep that data transactionally consistent across them, while making the data that the user's trying to talk to close to the user and be really fast. Okay, here we go. And we're making the file. There we go. New text document, the most important document. And you see it showed up on the right there. Okay. Now let's go ahead and load up the copy of that same project, but now this copy is pointing to the storage that is mounted to our Spoke file system. And already right away, you can see that we loaded up super fast. Right? This is essentially the same performance that we were seeing before when we were local. And I'm just showing you here that this is that same path that we were just showing you the connected namespace in. Right? We hit play, and right away you can see this footage isn't choppy, but like your editor can view the footage and see what's going on and get their job done, while sharing all of the data in real time with whoever they're trying to collaborate with. Just going ahead and scrubbing the video to show that our adaptation is still working even across the Cloud Data Fabric. So this is, again, the same kind of like conceptual model that I told you about earlier, where first we go and as you're far away from the data, we ask to get that data in from your remote cluster. We cache it in your local cluster. And as we get closer and closer, we cache it in local NVMe, then in RAM. And that's why we're able to really kind of get this performance. We're predicting even further out and making sure that the user is able to get the data that they need.
Fantastic. Yeah, that's amazing. I mean, Matt, I think there were some subtle things there that, because I think you're, in my opinion, a pretty humble engineer, you skipped over quickly there. But the fact that the moment you instantly created the text file, it showed up on the other side, almost instantaneously, which is amazing. Absolute strong consistency without having to copy or mirror data is amazing. To be able to have the latency across those connections in a hybrid environment and then have it run, not only load immensely faster, but basically play almost instantaneously with, very few if any frame drops, really takes the idea of being able to collaborate in a hybrid or geo-distributed environment to a whole nother level. And I think the nice thing is, again, the way we've done this from a digital twin regression testing model is being able to identify the most common workloads and then go build those and train the model to optimize for it. Premiere Pro, which you just showed there, but also PyTorch and Palantir for an AI/ML data acceleration perspective. Petrel, extremely high performance workload in the oil and gas sector. A large variety of PACS and healthcare DNAs to accelerate radiologists look at the data and getting them highest performance. Maya, Flame in the media space, and I think in particular, like I talked about, Flame is one where I did not think that was going to be something that would ever work on Qumulo because, or any file system because of the difference. But we had some pretty astounding results after creating a digital twin and training on the model. So before NeuralCache, we're getting about 2.6 milliseconds on Flame, which doesn't sound like a lot, but ask an artist if they'll tolerate that. Absolutely not. And so in contrast, now what we see is sub-millisecond read performance, 4 times faster improvement, really making it a completely night and day difference to an end user artist experience. For DICOM and medical imaging, a 12x improvement down to 6.4 milliseconds. Petrel, 25x improvement down to 1.7 milliseconds from 44%, which for one of our large customers who are collaborating with on this. This was 3 times faster than their on-prem scale-out NAS from another vendor, and twice the performance of the highest performing alternative option in Azure. So just immensely more capable. It's just a really weird place to be able to say that you have, higher than normal high performance file system performance at near approaching the cost of object in an extremely elastic and scalable way is really a game changer. And so, look, we can talk about it, we can show you. I think even more powerful than any of that is actually just having one of your peer customers trying to solve world problems in one of the most difficult landscapes across, at least from my opinion, from an industry perspective, which is media and entertainment. It's where Qumulo and former companies I've worked with kind of got their start, because the old saying goes, if you can make artists happy, then you can probably make any other workload happy and work well. And with that, I wanted to introduce Jeff from Carbon. Jeff, maybe you could just a quick introduction about yourself and what Carbon does.
Hi, thank you. My name's Jeff. I'm the Director of Technology over at Carbon, which is a design and animation visual effects company that specializes in the advertising space. Most of the work that we do is short form, 3 minutes and less, although there's a variety of stuff. General sort of background, Carbon was probably about 15, 20 years old, but we made the move to AWS and changed our infrastructure to cloud-based for all of our Flames, all of our visual effects workstations about a little over 3 years ago. And at this point, we're 98% in the cloud. All of our artists work directly from there.
Wow. I mean, I can't imagine what that transformation was like in the first place. But it's interesting, when we first started talking, Jeff, you were actually on what I would consider the biasly the best alternative to Qumulo at the time, from a kind of a really next gen file system leveraging S3 as well. Maybe you can kind of set the stage a little bit for what the workload was like and how artists kind of came in on a week by week basis, how they interacted with the storage. What was the end user experience? What was your management experience on that prior technology?
Sure, happy to. So, I mean, before it went to the cloud, the Flames general, which create probably a good half of our user base, we're generally reliant on singular storage systems, privatized towards themselves, because latency and bandwidth are such a thing for them. But obviously that model didn't really fit all that well into the cloud. So we had to generally refit them around a central storage unit. And we ended up choosing a particular storage unit at the time. It was built very similar in a sense with NVMe cache in front of an S3 storage unit. But in order to do that, we generally had to effectively size the cache big enough that it supported the artists keeping everything on the cache. Like the S3 portion was really only to increase the overall size of the file system, but anything they were using on a day or a week basis pretty much needed to reside on that cache. And so as a result, it had to be built very, very large. I think I was looking this up last night. We essentially figured about 2 terabytes per artist in cache alone, just to keep that stuff up front. And with that, we generally had to, like, the only real tool that we had in our place was essentially like touched oldest. Things would have to age out after 2 days or 3 days. We actually had the policy set specifically such as if you're working on Friday afternoon, it would still be hot on Monday. And anytime like a long holiday weekend came in, like Monday morning, it was just like this slog of everyone trying to slow it, playing down their cuts over and over again, trying to bring it all back so they could get the work done for the week.
Wow. So the storage had a bit of the Monday, so to speak, in those circumstances.
Right.
Okay. So it sounds like you had, pretty active hands-on management to make sure the data was always in the cache ahead of time, that it wasn't getting aged out, that you were kind of managing that capacity pretty actively, that the whole working data set the artist might have to use was already there, ready to go. So, S3 based, but kind of an offload, not an active use of it.
Exactly. I mean, where it even got into your way, where it's like, if, with the 3 days, like by the time Thursday hit, you're automatically starting to drop stuff for Monday, and that might not be ready to go. So I don't want to make it sound worse than it was, but you are effectively kind of bailing water to make sure that you stay in front of where you need to be to keep the artists happy.
And was there ever, I mean, an experience for the artists to see any of this complexity, or did they ever? I mean,
very much so. I mean, the Monday morning challenge was definitely was there, where for them they would literally be sitting down and playing down the edit multiple times. Like you hit upon it a little bit in your discussion on NeuralCache, like the way that it has to know how to read. Since Flame is sort of a very spread out file system and based on individual frames, it would read like frame 1 and 2, but then it would forget about 3 through 7, and you'd have to wait till the second and the third playdown. So usually, it could take an artist, depending on how cold the stuff was and how much media it was, half hours of playing down the cuts and stuff like that to bring everything back.
Yeah, and so when we engage and talk, I think at NAB, like at the big trade show for media, right? So the idea was, how can we ultimately help maintain or actually improve artist experience while getting you to a place where you could try to size down the environment from an AWS infrastructure perspective to be more cost effective, and also hopefully improve the manageability of that on your team's shoulders as well. Maybe you could talk to me a little bit about what that contrast was like with cloud native Qumulo and NeuralCache in place compared to the prior technology.
Right. I mean, I remember that NAB very, very well. It was surprising because it's more that the NVMe is the sort of throughput for S3. Like we weren't in all the conversations. I think I kept bringing up but how big of a cache do I need to, it's like we don't need to be so concerned about that. It's more of the pass through, worry about the prefetcher and make sure that that's pulling stuff in for you quickly. And I mean, the end result is that NVMe tier that we have relied upon in the past is essentially about, I think it's about an eighth of the size of what it was originally. And so that 1 to 2 terabytes per artist, like essentially dividing that by 8, only keeping that stuff in. And the honest reality is that they would cross that barrier on a day. So the simple cycle of data that's coming through there based on NeuralCache, based on the prefetcher is staying in front of them. And as a result, there's not really those Mondays so much anymore.
So no more case of the Mondays. That's good. The artists are happy. You could size it down to a fraction of the size of that expensive NVMe to support that workload and keep all those Flame artists happy. And then hopefully also, I think I heard you say, just not really having to manage that as much and kind of be on top of it like on a regular basis.
Yeah, admittedly, in some ways, I'd almost want to manage it more. I'm because I'm a little bit of a control freak and doing these things. It's like want to be able to touch and say evacuate this and that. But the honest reality is that you're kind of along for the ride. And as long as the artists aren't complaining, we're good. Like storage can be, if there's no complaints about storage is great.
Yeah, well, I do have, by the way, I have to really thank you because the partnership has been fantastic. The ability and opportunity for us to create a digital twin on your workloads, go optimize for that, come back and see the difference really benefits everybody else out there. So I think there needs to be some type of reward system for Carbon for being a trailblazer in that space to make every other Flame and Maya and workload out there doing really humming along well. So thank you so much for that. I guess my final question would be, any last comments or feedback for Qumulo and how we've been to work with or what we could do better for you?
Right. I mean, I think you hit it right on the head there. I mean, even since April of last year, it has been a partnership as we sort of talk through and understand the different details of how it all fits together, and working directly with your support departments and your dev teams and stuff like that. We're sitting down with your dev team and with the Autodesk Flame dev team and us, working on our Flames, going through cuts to make sure that you understood exactly what the Flame was expecting, and then everybody's sort of holding hands. And so it is, in that sense, been a partnership. And literally the first thing that happened was here's the Terraform code you need to start the cluster, and the second thing is here's the Slack channel that you communicate to us, ask us whatever you want, and it's 30 seconds to get. I don't want to promise that as an SLA, but it's been.
But
really
hey, That's
to work
that's your experience, right?
with.
So
Yeah.
awesome. Well, I can't thank you enough again across the board from the Qumulo team in the partnership. We've really enjoyed it. I think the results have been just they've definitely exceeded my expectations for, before and after, and I can't wait to even do more with you in the future. So thank you again so much.
Yeah, mine as well. Thank you.
Okay. Thanks, Jeff. Now moving along, I think, the best way, by the way, for everyone out there that's curious, that sounds too good to be true. I don't believe this. Awesome. Great. Don't. Go try it. So it's really easy. You can go to Qumulo.com, get started, or visit us in any of the large cloud marketplaces, spin up a cluster in sheer minutes, and be able to take it for a test drive. And you don't even have to talk to us if you don't want to, but we're here for you, of course, at any moment in time. And we absolutely look forward to new, even more challenging workloads we haven't come across yet before, as keeping Matt and the engineering team excited and busy to solve big new problems. So I encourage everyone to give it a shot, and proof's in the pudding. Take it for a drive and see where it goes. So with that, Dan, I think I'll turn it back over to you on if we have any more questions to talk through.
Yeah, we have actually a few questions that have come in the past 20 minutes or so. We'll go probably to the top of the hour, maybe a few minutes over, but after that, we'll cut it off. But feel free to keep dropping questions in. Question number one, is the system able to accommodate multiple streams for multiple locations, even with differing latency and no significant frame drops? Not sure if Matt or Brandon would be better for that
Yeah, I
one.
mean, I think we have customers, media is the largest install base for Qumulo customers today, across the board. And so the great part about that is we get extremely challenging workloads to test everyone in product and engineering. And so, yeah, being able to have multiple spokes across different teams and different locations is a core aspect of how Cloud Data Fabric works. We went into much further detail on it in a prior webinar. You can go take a look at that as well. But being able to optimize accordingly for whatever's necessary to get the best output. The nice thing is that it's a training model that looks at simply how to make those end users as absolutely happy as possible and do whatever necessary to get there. And so it's always looking from a pattern matching perspective and preemptive caching perspective to make it the absolute best experience it can be, even across that multi-dimensional environment.
Great. Another question, which I think really is around how CDF functions and what the capabilities are. If I change one tiny part of a file, maybe I just make a little edit to that video across the globe, will that change instantly show up in on the other side?
Yes. Very simple answer there. Yes.
Fantastic.
And Matt, the funny part is, so, as you remember, I was probably the most skeptical of anybody on Cloud Data Fabric before it came out. Just too many attempts by too many different companies to layer on top or to, race speed of light, physical, lock contention problems and stuff like that. I didn't quite appreciate an aspect there, which is, the ability to stream blocks between those two systems or multiple systems, not at the file level, but at the block, 4K block level, and dynamically change that on the fly as needed, and really be unbelievably efficient at what data is moved only when necessary or preemptively at an extremely granular level. It's amazing what can be done when you actually go down below the file level and protocol level to connect those systems together.
And to clarify one thing there, the one piece of the power I think here is the fact that it's not just going to show up quickly, it's going to be transactionally consistent. So whatever the protocol semantics say about it, if you had two clients accessing that same file on the same local file system, is exactly what we will do across the Cloud Data Fabric. So if you have some application that is relying on that, as soon as you get the response back that says that it's written, the next read will see it, regardless of whether that next read is local to where it's where the home of the data is, or if it's on some spoke somewhere, or even if the write was done on a different spoke than the one you're trying to read from. It is transactionally consistent all the way across the network. Very strong transactional consistency. So that's real power right there. And I don't think that that's something that anyone else can really claim.
I love,
But
by the way, that the bar is set so high. It was just an absolute, unquestionable minimum expectation that the system under no circumstances would do anything but absolute transactional consistency with no ability to corrupt and yet still make data, virtually instantly accessible from any place, read or write on either side of that relationship is just, it's amazing. I really appreciate taking the long, hard way to get there versus the shortcuts that are aplenty.
Yes. Thank you.
Another question, which I really like this one. Is there a catalog of applications that are known to NeuralCache?
So I think I'm probably the right one to answer that question. And the answer is no, but yes. So the first part of my answer, the no, is that in the product today, we do not have specific application behavior encoded into the NeuralCache. The but yes part is the behavior in the product is based on what we have learned from a large catalog of data that we have on our side. And we have a set of particularly important curated data there that we use to make sure that as we make changes, targeted applications will not see regressions in their performance from our changes in behavior. And that is, unlike a live performance test, that is something that the system can just go and work out on itself much faster than real time, even of the application running. Because these are just the kind of simulations that you use when you're trying to tune the system, right?
Yeah, I think it's a byproduct of, again, the amount of exposure against all the different workloads and different industries that Qumulo's in today, serving customers and making that happy to then populate that data set to feed those things. Extremely wide variety across, media and automotive and oil and gas and healthcare, life sciences, and you name it, we could keep going, but there's a lot in there. And I think the cool thing as well, like we saw with Jeff at Carbon, is the ability to then take anything novel and then immediately regression test on that to be able to optimize and come even better out. So it's the first time really I can say in all the years I've been working with product teams on different storage platforms where it wasn't like oh, sorry, that's not a great performance. Well, we'll think about what we could do and get back to you on the next major release in 6 months, 9 months, whenever on the roadmap we can fit it in. But something that it can be very actively worked on in collaboration with us in mere hours to short days, and being able to turn around and see a pretty drastic improvement in testing on that new behavior. So it's amazing to have a path to quickly learn and make it better for any of those new things we come across, which we saw with Petrel, we saw with Flame, we saw with a lot of those.
Yeah.
And a follow-up question there, I think to add on to that, is there a process to request new applications be monitored for addition to the NeuralCache portfolio to make it more intelligent?
Yeah, I think the path is what we do with all of our customers today, which is, every customer gets by far the most white glove customer success engagement I've ever seen in any company. Dedicated Slack channel, CSM, and able to that's your path to the company to be able to do things like this. And so that just creates an instant way to communicate and collaborate on getting that and progressing it from that point.
And to clarify that, that is already a tested path where customers have seen something that they were confused about or didn't quite like, gone through that escalation path, gotten solutions quickly to their problems, and are in that regression set already. Like that is not that is not a hypothetical path. That's a very real path.
Yeah, and by the way, I just love the fact that, again, it's I think in prior environments I've been, something novel and challenging is like, oh my gosh, what do we do? This is so difficult, how to solve this customer problem. And it's amazing. It's almost an opportunity now because now we get to go figure out how to make that just scream in performance. And then once that's in there, it benefits everybody globally ever doing that same thing. So it's really actually a huge benefit to have customers bring those new things to us.
Yeah, or even vaguely related things. Like
Yeah.
for example, we went and when we were first learning about like oil and gas workloads, we went and we trained on a whole bunch of Petrel data. And then all of that data, it turns out that a lot of those I/O patterns look to our cache very similar to other applications in the same space.
Yeah.
So it's kind of important that at the end of the day, the changes to the behavior of the cache are not necessarily specific application dependent, because these are generalizable patterns that we can then pick out in other applications across the industry or potentially across industries, plural.
Awesome.
Yeah.
A couple more here, and we'll wrap it up. Someone had a question about the demo, and they said, they asked it, okay, I see it's with Windows Explorer. How does it fare on the Mac OS Finder, especially, with column view, thumbnail view? They're asking kind of, is it caching remotely, or is it just showing the file, or does it stay an ephemeral file? I think they're kind of asking, like, what's actually going on underneath the covers? Is it going to have to pull the whole file into cache, and potentially even if the file's not being opened, because Finder likes to be helpful and show you previews of things like inside that file explorer.
Yeah, so we're generally speaking, we're agnostic to the client. It doesn't really matter to us whether you're in Windows Explorer, Mac Finder, your favorite Linux file browser. They have some mildly different behavior from each other, but we're aware of that. We test all of those, and they should be performant. Specifically, there's a kind of second part to that question, which is about the caching involved. And the answer there is a little bit fuzzy, because the answer is whatever the predictive engine thinks you'll need is what we'll go and try to cache. So I don't have like a hard answer of it'll cache this, it won't cache that. But the idea is that it's going to go and try to pull in the data that it thinks you'll need, and it doesn't have to pull in whole files. It knows how to pull in bits and pieces that it'll think you need. And specifically on thumbnails, there's often actually hidden like alternate thumbnail either the files or data streams that are not necessarily all the same. So there's some extra weirdness going on there. But the idea is that we have this predictive engine that is going to go and figure out what it thinks you're going to need, given the access pattern that your client is doing. And it should do a pretty good job, and you should see good results.
Yeah, I would think, especially in the media space, a good chunk, if not majority, of our customers are actually interacting on the Mac side.
Yeah.
And one last question before we wrap up. I think this is, probably one of the most important of all. But is this dependent on cloud? I.e., is this only available in the cloud? Do I have to use a Qumulo cloud product, or can I, do this on-prem as well? Completely separate from the cloud, or is there still a dependency on the cloud even if I'm doing this on-prem?
No, I mean, sorry, go ahead.
I was going to say, again, I'm going to go for the nuanced answer. I'm going to say no, but yes. So the answer is, your cloud data fabric, your caching across these relationships, all of that stuff is completely agnostic to where you're running and the underlying storage. There are some cloud-specific pieces to this, like, for example, Brandon was saying earlier with our object coalescing. That is an object-specific feature. There's not really a direct analog on-prem, because we're not using object storage as your backend storage on-prem at all. So like there's a couple of pieces here that are cloud specific, but really the broad answer to this is it doesn't matter where you're running, we're going to make it good. And all the on-prem is included in that.
Yeah, it's kind of like yes plus. Like yes to all
Yes.
that. In cloud, we have to do a little bit more because we don't want people getting burned on API costs and other things along those lines. Yeah.
Yeah, but to be clear, we have separate optimizations to optimize the right patterns for things like on-prem hard drives and stuff like that. That's all.
Yeah.
That's all there.
Awesome.
Yeah. All right. Thanks for the answers. Thank you to Brandon, Matt, and Jeff for being a part of this webinar today, and thank you everyone who attended. This will be available, I think, on YouTube potentially after this, available online if you want to review it later. And thank you for your time today. We will see you next time. We'll be doing these webinars on a fairly regular cadence, so stay tuned for the next webinar coming up soon.
Awesome. Thank you.